Hello everyone, welcome back to my channel. Today in this video we will be discussing SEM 3, sorry, SEM 5, that is linear algebra. So your first unit contains vector spaces which has vector spaces, subspaces, null space, column space, linear transformation. So the questions you can expect is from this one: linearly independent or linearly dependent. So they'll be giving you a set and they will ask whether it is linearly dependent or independent. This is a must question in your examination. And coming to the second unit, that is rank. Rank, change of basis, eigenvalues, eigenvectors, and characteristic equation. So by using these characteristic equation, you will be asked to solve eigenvalues and eigenvectors. So one question is must in your short. That is for one question will definitely come for short. That is for 3 marks for your pandemic. Like I'm telling about the pandemic pattern. And the second is in your long answer, you will get it for 15 marks. So one question from eigenvalues, eigenvectors. That is overall you will get 2 questions from this second unit. You will get 2 questions. One they'll ask you for short, and the other one they'll ask you for long. Now coming to unit 3, diagonalizability is a must question, a very important topic. Just by studying this diagonalizability, eigenvalues, eigenvectors, and linearly independent topic, you can just attempt the almost two-fourth of your paper. So make sure that you don't leave this topic at all, diagonalizability and even eigenvectors in this. And then sometimes they'll be asking you linear transformation in your short or even in your long. And next, coming to fourth unit, orthogonality. One question is must from the orthogonality question. So in this overall unit, the overall syllabus, you don't have to miss linear transformations topic, linearly independent, eigenvalues, eigenvectors, and then diagonalizability and orthogonality. Make sure that you are very perfect with these topics so that you'll attempt entire question paper. Now, today in this video, I just wanted to tell you about eigenvalues and eigenvectors. Before proceeding into the video, I will give you a quick definition of eigenvectors or a characteristic vector. Eigenvector or a characteristic vector. So the eigenvector or characteristic vector, they are given as any non-zero vector x. Like if there is a non-zero vector x, this is said to be an eigenvector of a square matrix. Remember, eigenvalues and eigenvectors are like mostly found for the square matrix. What is square matrix? Like if you have a 2 by 2 matrix or a 3 by 3 matrix, right? Or like mostly for your BSc, you'll be just asking for this 2 by 2 and 3 by 3, so you don't have to study further. So if X is a non-empty vector space of a square matrix A, then there exists a scalar. There will be existing a scalar lambda such that this AX is equals to lambda X. Okay, AX is equals to lambda X, where this X, whatever X is called, is there now. This is called eigen or a characteristic vector. And the scalar, what is a scalar? This lambda is a scalar. So this is the scalar which is called eigenroot. Remember that the scalar is a root. It is known as eigenroot. Okay. Now coming to a very important definition, that is characteristic equation. Without this, you cannot be solving this eigenvector definition. Problem. So what is a characteristic equation? Just remember that a minus lambda I is equals to 0. Actually, you will be having a proof on this. I'm not going to tell this in this video because it will be a bit long. So just remember that. What is characteristic equation? This is determinant. So det, it is in short form, we'll tell it as determinant. That is det a minus lambda I is equals to 0. So make sure that whenever you listen to the word characteristic equation, remember this one. Now I'll just move on to the quick problem of the eigenvector. So the question is given as, is 1 4? They are just asking, is 1 4? an eigenvector of -3, 1, -3, 8, that just asking, is this the vector of this matrix or not? So for that, what is that we have to find? We have to first assume this, that is A is equals to -3, 1, -3, 8. Take the matrix and just take X, that is vector is equals to 1, 4. Okay. So now what we have to do, what is the eigenvalue or eigen characteristic values formula? That is the definition. Ax is equals to lambda x. So what is Ax? Just multiply this and this. So what is that? You'll get -3, 1, -3, 8 into, I hope you know how to multiply the two matrices. Like you have to multiply like this. 3 into 1, -3 into 1, -3 plus 4, and this is -3 plus 4, and then this -3 into 1, -3, and this 8 into 4, that is plus 32. So what is that you'll get? This is equals to 1 and 29, right? So they are asking Ax, whether Ax is equals to lambda x or not. So do you think, like, what is Ax? This one. Ax is equals to, what is lambda that you got? Lambda into 1, 4. So do you think these both are equal? Like Ax is equals to lambda x. When you multiply Ax, you got 1 and 29. So if you multiply anything into lambda into 29, there is no multiple of 29 and 4. So you can tell that Ax is not equals to lambda x. Okay. And then we'll do one more question based on this. There they directly gave you the vector. So in exam, normally what is that they'll ask you is, I'll just pick a question from your previous question paper, that is June or July 2019's question paper. They asked you a question, that is question 4 in first bit. They asked you, find the characteristic polynomial and real eigenvalue of the matrix. So the matrix they gave is A is equals to -4, -1, 6 and 1. This is what they gave. So what is that they are asking? They are asking a characteristic polynomial. I hope you all know what is a polynomial. So let us just solve this. So first consider what is that they gave. What is that they gave? They gave this one. A is equals to -4. A is equals to -4, -1, 6 and 1. So now what is that you have to find is the characteristic. First find the characteristic equation. So what is the characteristic equation? That is determinant of A minus lambda I is equals to 0. So how will you find A minus lambda is equals to 0? This is, just first write down the matrix of A. That is -4, -1, 6 and 1. This is the matrix of A. Minus lambda into, what is I? With respective to a 2 by 2 matrix, you have to find an identity matrix. That is 1, 0, 0, 1. Okay. Now you got to have a determinant. So how will you find this one? 1 second. Yeah. So this will be equals to -4, -1, 6, 1 minus lambda into, that is you can directly multiply lambda with this one. So what is that you'll get? Lambda 0, 0, lambda. Now subtract these two matrices. What is that you'll get if you subtract? This is equals to -4 minus lambda, -1 minus 0. And this 6 minus 0, 1 minus lambda, right? This is equals to 0. Now, how will you find the determinant of a 2 by 2 matrix generally? How will you find the determinant of a 2 by 2 matrix? So, if you have A, B, C, D. So, how will you find the determinant for this? You just have to cross multiply. That is AD minus BC is equals to 0. The same thing comes here. That is AD. What is A? -4 minus lambda into 1 minus lambda minus of -1 into 6. So what is the equation that you will be having? Lambda minus 4 plus 4 lambda minus 4 plus 4 lambda minus lambda plus lambda square plus 6. So if you further simplify this, what is the equation that you'll get? Lambda square plus 3 lambda plus 2 is equals to 0. So this is what the actual equation is. Now they're asking us characteristic polynomial. So for characteristic polynomial, what you have to do is this lambda square plus 3 lambda plus 2 is equals to 0. You got to write its roots. So if you find the roots of the lambda square, what will be the roots of lambda square plus 3 lambda plus 2? So that is, the roots you'll have is lambda is equals to minus 1 comma minus 2. So this is actually a characteristic polynomial. So which degree polynomial is this? 2 degree, because you have 2 over here. Lambda square plus 3 lambda plus 2 is equals to 0. So the characteristic polynomial is lambda square plus 3 lambda plus 2 is equals to 0. Or you can write this in terms of a also. So what are the roots that you'll get? You'll get minus 1 and minus 2. So they're asking you the real roots. So minus 1 and minus 2 are the real roots for this given equation. Okay, I think I'm clear with this. Let's look into another problem. Now see here, as they in the question, what is that they actually asked you in the question? They asked you just eigenvalue. Now suppose if they ask you an eigenvector, you got to do it like you have to further calculate it. So just as they just asked you eigenvalues, you just got these, like you just got these one, that is lambda equals to minus 1 and minus 2. You just have to stop till here. If they ask you for eigenvectors, you have to further continue, that is take this lambda values, that is lambda is equals to minus 1, and then substitute it over here, and then in case 2 take lambda is equals to minus 2 and substitute it in here. So I'll just 1 second. Yeah. So I'll just give you another question and I'll show you how to find the eigenvectors. So if you have a question like this, yeah. So there's a question says find the eigenroots and the corresponding eigenvectors. So they're asking us to find the eigenvalues and eigenvectors also. For A is equals to 1, 4, 3, 2. So this is they just gave the matrix and they're asking us to find eigenvalues and eigenvectors. So what is the first thing that you have to do? You have to find a characteristic root for this. That is characteristic equation. What is that? A minus lambda I is equals to 0. So what is A? Determinant. So what is A? A is 1, 4, 3, 2, right? Put that in a square form, minus lambda into, we are talking about 2 by 2 matrix. So that will be 1, 0, 0, 1. So put that in determinant and write that is equals to 0. Now write, like substitute this 1, 4, 3, 2 minus, what is that you'll have? Lambda 0, 0, lambda. Now you just have to subtract. So what is that you'll get? 1 minus lambda, 4, 3, 2 minus lambda, this is equals to 0. Now you have to find the determinant for this. So what is that? AD minus BC. Minus 1 minus lambda into 2 minus lambda minus 12 is equals to 0. So what is that you'll have? Lambda square minus 3 lambda minus 10 is equals to 0. So what will be the lambda values? Lambda is equals to minus 2 and 5. Minus 2 comma 5. Okay. Lambda equals to minus 2 comma 5. So what are the roots of the given matrix? Roots are, that is eigenroots are, lambda is equals to, that is eigenroots are minus 2 comma 5, right? Minus 2 comma 5. Now till here it is finished. Like whatever roots they asked us to find, we have found those roots. Now we have to find the eigenvectors for the given matrix. So how will you find? First substitute lambda is equals to minus 2 in the given equation. So what is that you'll get if you substitute case 1? I'm just considering this as case 1. So in case 1, put lambda is equals to minus 2, or let lambda equals to minus 2. Now consider, what is that we have the matrix? You have 1, 4. Like in place of lambda, you have to put minus 2. So what is A? A is equals to 1, 4, 3, 2. And in place of lambda, you have to put minus 2. So a minus lambda I. So what is that you'll get? If you put 2 in place of lambda, you'll get 1, 4, 3, 2 minus lambda, right? Like, no, what did you write? Minus lambda of 1, 0, 0, 1. You got to put minus 2 in place of this. So minus into minus becomes plus 2. So plus 2 into 1, 0, 0, 1. So what is that you'll get? This is equals to 1 plus 2, 3, 3, 4, 3, 4. You'll get 3, 4, 3, 4. Now from this, what is that you have to find is the augmented matrix. So the augmented matrix. So what is the augmented matrix? Is Ax into B, or AB. If you write AB, so what is that you'll have? This will be A plus 2I and 0, as there is no B term. So how is that you'll write? You will get another column, that is 3, 4, 3, 4 will be like that. You'll get another third column, that is 0, 0. Okay, this is the other matrix. Now what you have to do is you have to perform row operations to make sure these are zeros, like the second row, the last rows are zeros. So how will you perform the row operations? R2 tends to R2 minus R1. So if you perform the row operations, what is that you'll get? So what is that you'll get? This implies 3, 4, 0 will be as it is, and this will become 3 minus 3, 3 minus 3 is 0, and 4 minus 4 is also equals to 0, and 0 minus 0 is however 0. So this is 3, 4, 0, 0, 0, 4. Now you have to put these in a variable form. So this will be 3x1. That is, what is B here? You have to multiply this with x1, x2. x1, x2 is equals to 0, 0. So what is that you'll have? So you will be getting 3x1 plus 4x2 is equals to 0. And however, this one is however 0. So what is that you can get from this? You can write 3x1 is equals to minus 4x2. From this one, what is x1? x1 is equals to minus 4 by 3 into x1, x2. Okay, so now we got x1. Put that x1 aside, and now see, we got x1 and x2 is a free variable. So you have to say that we got x1 and x2 is a free variable. Here write x2 is a free variable, right? Now see, so what is the general solution of x? Actually, x is x1, x2, right? But what is that we got x1 as? x1 as we got like this, minus 4 by 3 x2 and x2, right? So this is equals to, we have x2 is common, take x2 out. So if you take x2 out, what is that you got? Minus 4 by 3, 1, right? Now I don't want this in a fraction form, so I'm just multiplying with 3 on in this row and this row. So what is that you'll get? x2 into minus 4, 3. This is what the vector is. This is we got only for x2. Now with while using lambda is equals to, now case 3, sorry, case 2, by putting lambda is equals to 5, we will get x1. What is that? A minus 5 lambda. So instead of lambda, you have to put 5. That is, sorry, 5i. This is 5i, lambda I, no? So 5i. So 1, 4, 3, 2 minus lambda, that is minus 5, 1, 0, 0, 1. So what is the matrix that you'll actually get? So no, you don't have to put determinant over here because we are just normally finding that one. So what is that you'll get? This is equals to minus 4, 4, 3 minus 3, right? Minus 4, 4, 3 minus 3. In the same way, same thing, augmented matrix. What is an augment matrix? Augmented matrix. So what is an augmented matrix? This implies A minus 5i into 0. Okay. So write the same thing, minus 4, 4, 0, 3 minus 3, 0. So in the same way, you got to put row operations. If you put row operations, what will happen? R2 tends to, or first, just make it more easy, because I don't want this to be complicated. First, divide R1 with 4, R1 with 4, and R2 with 3, R2 with 3. So what is the matrix that you'll get? Minus 1, 1, 1, minus 1, 0, 0. Now if you perform some row operations, because I wanted the last row to be 0, right? So R2 tends to R2 plus R1, right? If you make this only, the last row will be equals to 0. So minus 1, 1, 0. So what will be the last row that you'll get? 1 minus 1 is 0, minus 1 plus 1 is 0. So all the last rows that we got is 0. Now you got to multiply it with x1, x2. x1, x2 is equals to 0. So what is that you'll get? Minus x1 plus x2 is equals to 0. This implies x2 is equals to x1, or x1 is equals to x2, or x2 is equals to x1. So now here also the x2 is a free variable. So what is the solution? X is equals to x1, x2. So this is equals to, if you put x1 as x2, you'll have x2, x2, right? x2, x2, or you can put x1 also. So if you take x1 common, what is that? You'll have 1, 1. Okay. So x1 is 1, 1, and x2 is, what is that you got previously? So what is that you got previously? See here, I'll just zoom it in. See, so this is the vector when you substitute lambda is equals to minus 2, and this is the vector when you substitute lambda is equals to 5. So what are the vectors that you got? Minus or 1, 1, minus 4, 3. These are the required vectors. Or if you don't want to put it in a matrix form, just leave it like that and tell this is a vector that you got when you substituted lambda equals to minus 2, and this is a vector that you got when you substituted lambda equals to 5. So make sure that you study eigenvalues and eigenvectors properly, and then study diagonalizable. Don't forget, don't at all miss these topics: linearly independent and then orthogonality. Study these 4 topics because they are very, very, very important. Just make sure that you go through the entire problem properly. If you have any doubts, you can ask me. Thank you.